Perfect. So all yours, Victor.
Okay. Hello, everyone. As Oscar told you already, this is going to be the second session of the webinars that we prepared for MINKE. We are going to cover a little bit more advanced subjects than we did a couple of days ago. I hope I explained myself properly during the webinar, and please, any questions that you have, I can answer them at the end. Okay. So as you can see on my screen, I will show you the presentation with all the content, but also we have on the side a terminal that we are going to explain later that will show us a way to interact with the kit that allows us to control and configure and debug in a more advanced way. This is one of the main parts of today's webinar, so it's going to be always with us on a side. Okay. So to be able to do what we're going to do on this webinar, we do need a computer. Any OS could work. We use a micro USB cable to be able to connect our kit to the computer and talk to it and interchange some data. Obviously, the kit, the Smart Citizen kit, we are using a Wi-Fi connection, so we can test and debug and see how we configure things around networks. And this is a specific tool that has different options, but we choose this one because it is pretty easy to install in almost all computers, and it's a very robust project that's very common for people that's not into terminals and stuff like that. So the idea is that we need a software to talk via serial terminal to another device, and the Arduino IDE, that's an environment to program microcontrollers, also has a tool to talk to them. And you even get, as a bonus, a tool to plot data, and we are going to see how we can use those. So it's pretty easy to install. You can find it on the net. Later on the presentation, we show the link to it, but if you search for arduino.cc, you will find a web page where you can download it, and it's free software, so it can be used without any cost, and it's an open source project also. It's the same as Smart Citizen. Okay, before we start with this console stuff and shell things, we're going to start with the simplest part is how do I update the firmware on the Smart Citizen kit? Okay, as you remember on the last webinar, we explained the data board of the Smart Citizen kit that has several components. The main components that we are going to take care today are the two microcontrollers. The SAMD21 is this small black box on the center, is the main processor that takes care of reading sensors, calculating stuff. All the main tasks are executed inside it. So the main firmware, it's the software that runs the kit. Let's say kind of his own OS runs inside this chip. But also the Wi-Fi chip, the ESP8266, that's his name, has a different software that runs, that's also customized. So updates on ESP are less common because it's a simpler piece of software, but still sometimes we need to update it. And the process to update the microcontrollers is different. So we're going to go one by one. The most common process is to update the SAMD21 firmware. We do it not that often, but every now and then we add some new features or we fix problems, etc. So it's you have to update it more or less often in terms of sorry, you have to update it more or less often. To update the firmware, you can check for new versions on the GitHub website. We have a repository with all the code is uploaded very often. And you don't need to remember the link because the kit will provide that for you automatically. So as you remember, the kit has a reset button on the side that we showcase here on this slide. Depending on the type of case and the type of kit that you have, you will find it, as you can see here, in different places. Maybe you will have a water sensors like this in MINKE project, and you will have to click it via an external, with a pen or something like that. And when you click this, this reset button twice, your kit will go to a mode where you can upload the firmware. Before doing that, it's important that you back up what we call your token. Your token is the ID that you inserted in the kit when you did the onboarding process, and you can check it with your smartphone. You can connect to your kit when it is in setup mode, as you did on the first time, and check the token. You can write it down if you haven't done it before, and then you can proceed with the firmware update. So for the update, you just have to click twice the kit. I don't know if it shows there, okay. So if I do click the reset button twice, you will see that the LED on the kit turns green. And in my computer, a new device appeared. This device showed like a pen drive, like a USB drive, where I can just drag a file and upload it to it. I'm gonna open a file browser. You will see it here, sorry. And if I go here, you can see SCCK21. I will have a link, an HTML file that I can open, and it will redirect me to a GitHub repository where I can download the firmware, okay? As you can see here on the bottom, I have the source code, but a binary file that ends with a UF2 extension. That's the one that we can use to update our firmware. If I just download that file to my computer, by clicking it, sorry, just a second, there you go. Then I have it here, the UF2 extension file, and I can just drag it to my kit. There you go. No. Sorry. Here. And put it here, okay? When I do that, the kit starts blinking green, and at the end, it reboots itself with the new firmware. As you can see, the device disappeared from my computer because the kit is already, again, working as a normal device, not as a USB storage device. And let me just fix this again. Okay. So here on the slide, you can see the link to the GitHub repository where you can download this file. And as you see before, if you put the device in update mode, you will have a link directly on your computer. As simple as that, the kit has a new version, and you're done with the SAMP update. Remember that in some cases, the firmware and on the ESP chip also changes. So to be sure about that, you can check it on the GitHub page when you download the firmware. If you also need to flash the other chip, they will appear together, both files. And also you can check it by connecting to the kit again, putting it in setup mode, as we explained on the previous webinar, and connect with your phone or a computer. If the ESP needs an update, a pop-up will appear, like the one on the screen, saying to you that you need to update that firmware. You also need just to download that file and select it with a file selector that will appear on the web page. And the update will be done via Wi-Fi, not via USB. So the kit can even be connected to battery. It doesn't need to be connected via USB to your computer for this update to work. Another option is to update it manually. If for some reason you think that you need to update the ESP firmware and the kit doesn't show to you the window to do it automatically, you can force the update. The procedure is the same. You put it in setup mode and red LED. You connect to it with a computer or a phone. And as you can see here on the screen, there is an info icon on the right side. By clicking it, you will get to this screen, and there is the option to force the firmware update on the ESP. And from that point, the procedure is the same as before. You will be shown a screen with a file picker screen where you can choose the file and upload it. Okay. Moving on. Well, that chapter allows you to have your kit updated in terms of firmware. You just need to do this if you find any change that can improve your version, and we publish those on the forum on a regular basis. Every time we have a new release, we publish it on the forum, and sometimes for a specific external sensors or stuff like that, we have pre-releases or minimal releases that can be more custom. So depending on the type of sensor that you're using, maybe you have a custom release, but that's for specific cases. Now, the next subject is how can you talk to your kit in a little bit more advanced way than using your phone and just using a button and the LED as a feedback. The USB interface for the kit allows us to have a text interface that we call the shell. In our documentation, there is a very detailed guide on how this works. I'm just going to go over a global overview of all the commands that you can use, but not all the commands, but the most important ones, and the type of things that you can do with this shell. The shell, let me open it so you can see it. When you install the Arduino IDE, the one that I told you at the beginning of the webinar, you will have a screen like this. And in the tools menu, you can select a port. A port means any device that's connected to your computer that offers an interface that can be a serial interface. Depending on what's connected on your computer, you will have several things here, and depending on your OS, you will have different names. In this case, the Arduino 0 is in fact the Smart Citizen kit, but in terms of a low-level USB codes, it's showcased as an Arduino. So if I select this one, I'm in fact talking to my Smart Citizen kit. To open the terminal where I can interact on real time with it, I can go to Tools, Serial Monitor, or just click this small icon on the right, sorry. That will open this window. That's at the beginning is like a blank window, but the output of the kit will show on the bottom, and on the top we have an input line where we can type comments. In this slide, as you can see the web page for the Arduino. There are two versions. They just released the beta version 2.0. We haven't tested that version enough, so we recommend you that for now you keep using the previous version. In terms of features for the things that we're going to do, they are the same. So there's no need to update yet. Maybe later we will test it and see that it works properly. Once you're connected to the kit, like I did now, selecting the port and opening the serial monitor, if you go to the top input field and just click enter, you will see that the kit responds with a prompt. Okay, that means that the kit is properly connected and it's alive. And it can interact with us depending on the commands that we send to him. Okay, the kit has a normal loop when it's properly configured, as you can see on the slide, where the output of the readings of the sensors and all the events that happen during the normal workings of the kit will be shown in the screen. In my case, nothing is shown because I haven't yet configured the kit. We're going to do it together to see how we can configure the kit via the shell and test other options and commands for advanced configuration. So the first and most common thing that we do in any new environment is just type help. Okay, I'm going to make my window bigger here so you can see it. Help, it's a command that has a lot of output. As you can see, is the command's name and a really brief description on how to use it and what it does. Everything on the shell is like kind of really scarce in terms of descriptions because the device doesn't have that much memory to store very big help descriptions and very big messages. So you have to get used to this kind of minimalist approach, no? But still, as you can see, you have a lot of different commands that allow us to do a lot of different things. I recommend you that when you start using the shell, give a brief reading of the help command to see what's over there. Today, we're going to check most of these commands in a not pretty in deep, but in a superficial way. So, moving on. Real-time output, as we talked in a second ago, the kit will continue outputting anything that is happening to him. As you can see now, for example, there is a message, error, token is not configured. That was because I clicked the button on the kit and the kit tried to start network mode, but he saw that there's no configuration, so an error is popped out, okay? If I click it again, he will come back to setup mode and as a red LED, and we will see the message that the ESP, the Wi-Fi, it's already up, offering a hotspot to be configured. When we configure the kit via or we interact with it via the shell, we don't need a smartphone to configure it because we can do it directly through this interface. Also, this interface is very good for debugging purposes because since we see all the messages of what's happening, we have a really good insight on the details of the errors, on what's a sensor being detected or not, if the readings are coming out at the rate that we expect, stuff like that. And also, another important thing is that you can integrate this interface with the scripts. We have a Python interface already set up, and you can use shell scripts or any type of scripts that you're used to program in your computer to interact with the kit in a more automatized way. So if you have to flash or you have to reconfigure 20 kits, building a script and using the shell interface normally tends to be the best approach for that matter. Okay, so passing to, in fact, some commands and their descriptions. The most simple one that will give us some info is the version command. As you can see the output here, it will give us a lot of numbers, but it's important because sometimes we don't really know which version of the firmware we're running. And if we ask for help in the forum or we send an email to support or something like that, that information is very valuable for the people that's going to help us. So here we can check if we have the latest version of the SAM chip of the firmware. You can even see at what time that version was built. The same for the ESP version and the ESP build date. And also there is this big number that's not really useful for us, but that identifies the chip on our smart citizen, and it's unique. And this other one, the ESP MAC address. For those that have a knowledge around networks, you know that a MAC address is a unique identifier of any network device. And this is pretty useful because when the kit showcase the hotspot to be configured, when we put it in setup mode and the LED is red, we will find an SSID of a network that's called Smart Citizen, and we add these 4 last characters on the SSID name of that network. So it is unique. And with this, you can know at which kit corresponds each of the Wi-Fi networks when you have more than one. Okay, this, as you can see, this command is just to get some information that's hard-coded in the kit. This information won't change unless you update the firmware on any of the chips. Then you can do commands that execute an action on the kit. For example, reset. Reset, as pretty self-explained command, is just the same as clicking the button on the kit, but via software. When we are configuring a lot of kits, sometimes it's easier just to send commands, or even when we do scripts. For example, we want to configure something and reset the kit so it starts logging, so we can just send this as a software command. Also, when it's difficult to access the kit because it is installed in some strange location, but we do have a USB connection, then we can reset the kit via software. I'm not going to do it right now because normally when you reset the kit, you lose connection and you have to reselect the port and reopen your serial monitor. Okay, but it's a pretty simple command. Now, we're going to start with the commands that have a little bit more complexity, and I'm going to jump between some commands because most of them are interrelated. So, sensor command. The sensor command has several functions. The simplest one is to list, as you can see here, all the sensors that can be connected and the ones that are in fact detected and connected to the kit. So after executing the command, a big list comes out. At the beginning of the list, there is the disabled sensors. Disabled means that we are not taking readings from them, but also all the possible sensors are listed here. Even if they don't physically exist in our setup, they are listed here, so you know which sensors are supported and that you can connect and can be used. As you can see, the list is very big, and at the bottom, we have the enabled sensors. This kit has only the default urban board, so we can only see this the default sensors. It doesn't have even the PM sensor connected, so we don't see it here. As you can see, the PM is listed on the disabled sensors. Okay, the kit has the firmware kit of the kit is designed so it auto detects the sensors when it boots. So if everything goes well and we connect external sensors, they should appear here on the enabled sensors automatically without us doing anything. Later, we're going to see how to debug when that doesn't happen automatically. Okay, then on the enabled sensor list, each sensor has some extra information. How often is going to be read and how many reading intervals have to pass for this sensor to be read. I'm going to explain a little bit more around that in a second. Here, this command allows also to enable and disable sensors. As you can see in the help menu, if we add the modifier disable, Modifiers normally have a, sorry, my English for this character is not coming, a dash. So dash disable, and then the name of the sensor will disable a specific sensors. One parenthesis around sensor names is that you don't have to type them exactly as they are shown here. The kit will try to do his best to detect, to guess which sensor you are talking to. For example, if I just write temp, since the only sensor names that start with those letters is temperature, I'm sure I'm going to get this one. Sometimes there are sensors that have the same words at the starting, so you have to type more information so the kit knows which one you're talking. If there are more than one sensor that has the same initial characters that you type, he will choose the first one he finds. Okay, so if I do sensor disable temp, I did it wrong. I don't know why. Let me check. Let's check the help. Help, sensor, shows and set sensor state or interval. Sensor, sensor name. So I have to put the sensor name before the modifier. Okay, let's try that. I write sensor, then the sensor name, temp, and then dash disable. And he answers to me, disabling temperature. And if I type the command again, now in the list, you see that temperature is not enabled. And if I search for it on the top, it should be here. Okay, so it's a disabled sensor. This type of settings are saved on internal memory in a way that even if we reset the kit, those changes will remain on memory. That's important to realize, because if we disable some sensors, from that point until we reflash the kit or we change the configuration, that sensors won't appear and won't be read, won't be enabled. So unless we go to the default settings again and we reset the configuration, or we enable them manually one by one. Okay. Around the changing intervals, we're going to come back to that in a second. Let's go for the next comment. Sensors, we can also read them. If I just want to know the amount of light, I can just write read and the name of the sensor I want, and the kit will answer me with the specific value for that sensor. This could be useful for testing and debugging purposes, but also remember, you can write scripts that interact with the kit, so you can have Raspberry Pi or any computer that's on the side of the kit and can take readings from the kit on real time that not even need to go to SD card or network, that can be just grabbed by the external device. You can take readings one by one like this, or you can monitor a sensor. Monitor is an interesting command because allows us to get readings from a sensor as fast as the kit can do it. For example, for educational purposes and for showcasing readings in some type of sensor, this can be very interesting. This command has several modifiers, the monitor command. So let's recheck help command and see what we can understand here. Monitor command is here. So continuously read the sensor. You type monitor, then a modifier, then a sensor name, or several sensor names that you can put together, separated by commas. Now let's try to review what's here. If you put the modifier -SD, all the data that the kit gets from the sensors on real time would also be saved on the SD card as a CSV file, but pretty fast. So if you want to monitor any specific metric continuously for an amount of time and save that to an SD card, you can just add this and then the sensor that you want to monitor. Let's try to do a monitor light. As you can see, the output is a little bit complex, has the ISO time, the timestamp for that reading, the reading itself, and then another number. Sorry, the opposite way. This is the milliseconds, and this is the reading itself. At the end comes the reading, and these two are related to the timestamp and how often we can get the reading, meaning 108 milliseconds passed since the last reading. So we're getting around 10 readings per second. These two values are interesting in some cases, but sometimes we don't want those. We just want the value. So this and this modifier allow us to remove these two columns. Let's try to do it again. And if I write again monitor light, but I add the no time, sorry, here, no time and no milliseconds, then I just get the reading of the light. This is very interesting if you have the Arduino IDE, because you can then plot these values, not only see them as numbers. Okay, as you can see here, if I block or unblock the light, you can see on real time the numbers changing. But seeing these numbers is not as self-explanatory as if I see them in a plot. So if I open the Arduino IDE without closing this yet and go to Tools, Serial Plotter, sorry, the opposite. I need to close this window and then go here and open the Serial Plotter. Let me put it on top. You can see that the values appear there on real time. And if I unblock or block the light sensor, I can see the data flowing. Okay, so this is pretty useful. There are several tools that you can find online to plot this type of values. It's just a chain of values that come one after the other. So any serial monitors that understands them and knows how to plot them can do it. The Arduino IDE is a good option for that, but there are several options. And you can plot also several values. For example, let's try to plot the light, no MS and no time, because that will confuse my plotting software. The light and which other value? Let's try humidity. No, I did something wrong. Let me check what I did wrong, because I'm just getting what value, one value. Ah, I'm missing a comma. Okay, we got it there. So we have two values separated by a tab. Let's close this window and again open the plotter window. And as you can see here, I now have two values. Humidity doesn't change because, well, the changes are pretty slow, but light, you can see it on the top. If I put my hand closer, humidity changes a little bit. If I even touch the sensor, you can see the changes, no? You can do this with as many sensors as you like. You can plot them all together, or you can save that data to the SD card or just watch it on screen. With the scripting tools, you can also capture this data to save it or use it in different applications on real time. Okay, now let's go to the next comment.